and share the screen. So we'll just back up, just quick overview of what to expect from today. That last week we started talking about the material for the quiz that you'll have this week. Again, it'll be on Wednesday this week, and it'll be going over more of the POSIX shell material. So we'll finish that up in like 10 or 15 minutes or so. We'll also talk about a little more shell stuff that's not going to be on the quiz, but will be super useful for the stuff that we'll get to at the end of today, Docker, starting our next topic. I'm curious, have people here heard of Docker before at all? A couple head nods. So we'll be talking about that this week and next week, and high-level ideas that, so Bash, the terminal, again, is like a easy way to interface with the computer, writing these scripts, a way to automate these working with remote machines. And Docker and this thing called Docker Compose, which we'll be getting to, are ways to work not just on a single remote computer, but on this like army of remote computers, controlling potentially thousands of remote computers at once. So that's what we're building up to today. The lab that you had last week, most of you have submitted the lab for that, so that's good. If you haven't, again, there's no time, there's no late penalty for not submitting it. But we'll also be talking about, or what the lab was doing, trying to get you some familiarity with some of these Unix commands that are not directly part of the quiz material, and in particular, things like working with processes and sending things to the background and keeping things running while your computer is not necessarily connected to the Lambda server. And the MapReduce homework, we'll talk about that as a building off of the lab. So again, yeah, we'll start here with the quiz in a second, but before we do that, any questions about anything before we get started? Okay, so the quiz, again, the practice problems come from this shell scripting. It's gonna be 4 problems on the quiz, so same format as last time. All the problems are just what we call sessions in the terminal environment, sessions in a shell, where I just give you a bunch of commands and you have to tell me the output of the very last command. And 3 of those problems will come from this page right here. There's 3 sections of these practice problems, so probably 1 from each section. And then 1 from the previous quiz. The most important problem on the previous quiz is the problem related to Git and the branches and commits and how all those Git commands work together. So 95% chance that the problem will be from the previous quiz will be the Git sort of problem. And if you don't feel 100% comfortable with Git at this point and with the branches and commits and how all those things work together, I would definitely recommend redoing the very first lab that we had from the topic 0, going over the Git commands again, that it will help you for this quiz, and it will also, we're gonna be using Git throughout the whole class, doing some weird things with it potentially, and if you go on to any sort of career that is remotely related to programming in any way, you'll be having to interact with Git. So it's will definitely pay off to review that topic 0 lab. And again, in that lab, there's a lot of weird edge cases that it talks about that you might have missed the first time, but it really does highlight most of the edge cases that you might come up with merges and branches and all of those commands. So in this shell scripting practice problems, the new problems for this coming quiz, this first one was pipes. And I think this is relatively straightforward. Again, the vertical bar pipes, just taking the output from the previous command to the left of the pipe and putting it as the input to the right of the pipe. And this grep command is very commonly combined with the pipes together. So you'll probably see grep on the quiz. Any questions about the pipes? Okay. The stuff about variables, I think this is where things start getting weird and tricky, and I expect most people will probably do well in the pipes. I think a lot of people will miss some things about the variables because the way variables interact with quotation marks is just legitimately weird. And in order to review this, so I'm going to switch over to a terminal session here in a second. But again, you'll be able to have these practice problems out in front of you. Printed out notes are totally fine for the quiz. And so I'd recommend writing down whatever we go over in the terminal session that's going to be helpful for you on the real quiz. Three things, or three types of quotation marks are in Bash. Three types of quotes, and they all behave differently. And so this is going to be different than like Python or other languages that you might have seen before. And you really have to have a good intuitive understanding about how these three quotation marks behave differently. So again, if we create a variable like this, var equals hello world, this creates the variable var right here, and I can do echo $var to anytime you have the $sign, whatever comes after it is going to be the name of a variable, and it's just going to substitute whatever that value is right here. The first weird thing about quotation marks, and this is all still review from last time, is that if you have double quotation marks, variable expansion happens inside of double quotation marks. So the act of replacing the value of a variable with the expression of the variable right here, we call that variable expansion. Variable expansion is replacing $var with hello world. And that happens inside of double quotation marks. So we can have something like var equals $var, and we get the results down here. If we are not inside of double quotation marks, but inside of single quotation marks, then variable expansion does not happen. No variable expansion in single quotes. So you have to pay very close attention on the quiz. I'm going to do my best to trick you by having lots of double and single quotes in the problem, and you'll have to know when you do the expansion and when you don't do the expansion. Any questions at this point? Yeah, question is if you're allowed to have the practice quiz with you, and the answer is yes. Any sort of printed notes, you could bring in a giant stack of textbooks, that'd be totally okay with me. As long as it doesn't require a battery, then you're allowed to use it on the quiz. So yeah, I encourage you to bring in the practice quiz and use the notes from that. Good question. Any other questions? Okay. The third type of quotation mark is the backtick. And the backtick on the US keyboard is in the top left corner of the keyboard, just below the tilde, looks like this. And here, so this is the backtick, single quotation mark. Easy to get these two things confused if you're reading quickly. And so you should make sure that on the font that's on the printout for the practice problems, you can distinguish between the backticks and the single quotation marks. But on the backtick, what this does is it actually evaluates whatever the expression is inside of here and returns that. So this will be a little bit easier to do if we say var equals echo hello world like that, and I hit enter. Then inside the value of var is not this entire string. Instead, what the computer does is it runs this command. Whatever standard out of this command is, it puts that in var, and then when we access var, it'll print out the result of this. So echo $var like this, it gives us hello world and not echo hello world. Very easy to accidentally add this echo right here when it shouldn't be there. I'll do another example of that real quick. So we've seen that there's this cat command, cat, and I'm going to use output redirection on cat. We'll create a file called TMP, very common name for a temporary file, and we'll just say, so this is a test hello world. So 3 different lines here. Press Control D to end that. All 3 of these lines right here have been put into this TMP file. If I type cat TMP, we get these lines right here. And so now if I say var equals cat TMP like this, then echo $var, we get all of these things right here as output. Question? It's a great question. So the question is, why is all of this on just a single line when the file over here was on multiple lines? And this gets us to another weird thing about variables. This is one of the things that's not going to be on your quiz because I don't know, just white space stuff is hard to test on a quiz, but this is something that you'll need to be familiar with. So what I'm going to do here next is up here we have echo $var. Down here, I'm going to make that $var inside of the double quotation marks. And so the expansion here is going to happen inside of quotation marks. And when I do that, the white spacing of the original document will be preserved. So if the expansion happens inside double quotes, white space is preserved. If it happens outside of double quotes, white space not preserved. Again, so testing on white space related things on just printed paper is a little bit weird. So I'm not going to test you on something involving white space on the quiz, but this is something that you'll just encounter at various points in the class. And so it's a good thing to know that double quotes preserves white space. Vast majority of the time, if you're writing code in the shell, writing terminal code, writing shell code, writing bash code, or any sort of POSIX code, if you're doing this variable expansion, 99% of the time you want it in quotation marks to avoid bugs. Unless you explicitly want to take advantage of removing white space, then do things in the double quotation marks. Yes? Yeah, so the great question. So up here in our backticks, we're using, this is like an actual valid shell command. The question is, what happens if this was not a valid shell command? I don't want to retype this in. I also don't want to press the up arrow to go all the way back. So I'm going to use my Control R hotkey and type var equals to get back to my command up here. The first time I pressed var equals, it took me to cat TMP right here. If I press Control R again while I'm already in the Control R mode, the reverse history search mode, it will cycle through all of the things that match this. So with pressing Control R only once gets you the first match, pressing Control R again gets you the second match, and so on. So that's how I got to this line right here, that line right there. And now I'm going to modify this so that it's no longer a valid shell command. And there's a lot of ways that I can do that. The simplest one is just to make this first command over here not an actual command. Make it obvious that this thing right here is not an actual command. And we hit enter, and we get an error message like this, just as if we had typed that in right there. The actual variable now is empty. Yes. When are they saved? Oh, where are they saved? This is a good question about where are the variables saved. And the answer is they're not saved into a file or anything on the hard drive. If we were to exit out of bash and come back in, so I'll just do that right now. I type exit, you'll notice I leave the Lambda server, go back to my laptop, come back up, come into my relog in, and I can now use the up arrow, go back to it. I guess var was already empty, so that's not super. Var not empty. Exit, relog in, and it becomes empty. Anytime you access a variable that's not defined, it always gets you empty. You'll never get an error message from accessing a variable that's not defined. So it's even more forgiving in some sense than Python. but also very easy to just have typos and have your code not do what you think it's doing. So yeah, so this is an ordinary shell variable that we're talking about right here, $var. If you wanted to make this variable visible to other programs, then you have to do what's called exporting the variable. Export var equals whatever. And now this makes it available to any program that you run from this terminal session. So when we get to Docker, we'll have to do this in a little bit. But what the export command means is that other programs will be able to see this variable, not all of them. But if you just created the variable like this, no other programs can see it. So yeah, again, variables not stored in a file at all. They're just exist in memory, just like a Python variable. If you did export $var, so the question is what happens if you do export $var, and the var is going to be expanded, and whatever's contained in that will be passed to export. So yeah, you can't do something like this. Always has to be in a form like this. Okay, so what's the weird? Okay, so I mean, things are a little bit tricky now. We have 3 different types of quotation marks, but my claim is also that like so far things make sense. It's not too complicated. Like it's a little bit to get used to, but it's not too much. Where things are going to get really weird. So let's start making 2 variables. And actually, again, while I'm here, another common mistake that people make in shell programming is to add spaces like this. If you do that, you'll get these syntax errors. What this is literally run this command, pass equals as the first argument and this as the second argument. You always have to have no spaces around the equal sign in order to assign variables. So here we have var, let's go foo, hello. So we have 2 variables now, and I want to make var equals echo $foo $var like that. And so again, the echo command will print out whatever's over here. Variable expansion will happen inside of the backticks. So variable expansion will happen here. Foo and bar will both get substituted right here. We can verify that with echo $bar like this and see that hello was substituted. And I guess actually here I meant to have that be var. The fact that I put bar right here, a typo. Bar was not defined at this point, so this thing evaluated to an empty string, and we only get hello right here. If I change this to what I meant to be with var, var is defined right here, so now I hit enter, echo that, and it does the substitution on both of those strings. Sometimes I want to substitute not just a single command, but an entire, or not just a variable, but an entire command. Pass the results of a command to the results of a command and evaluate that. We can't do that with the backticks, though. We can't nest backticks. So instead of backticks, there's an alternative form of quotation coding that you can do, which is the $ parentheses. So just like $ by itself means the thing to the right is a string, $ parentheses is a shortcut for the backtick, and it means execute whatever's inside of here. The only difference between this up here and this down here is syntactic. Do that and we get the exact same thing. The advantage of this down here is that you can nest these $ parentheses, and we could do something like echo hello world like this. And so whatever is the output of this will be passed to echo here, and then whatever the result of var is will be the second parameter to echo. Hit enter, output that. And so here, echo hello world. This command right here prints hello world. That hello world is passed to echo, getting the hello world right here. And this var over here, ASD gets substituted and we get that over here. So parsing through all of these things, when there's a big combination of quotation marks and these $ signs, can get a little bit hairy. Maybe another making it a little bit more hairy here, adding the single quotes around here. Again, the expansion does not happen inside of single quotes. So now this right here will not get expanded. If I hit enter and run that, we can see that this here did not get expanded. The echo did not get run, and it just got passed as a literal to the echo, and we get an output right here. So it'll be very, you have to make sure before the quiz that you're very comfortable with parsing through a line like this and figuring out which quotation marks and parentheses are active at any given point, and make sure you can interpret those. And the practice problems have a lot of weird edge cases to help you with that. Any questions about that? Okay. The last section of the practice problems then is about for loops in Bash. So we'll start by going through some simple for loop syntax, and then we'll see how all these quotation marks interact with it to make weird things happen. I don't know if we've seen this reset command in class yet, but there's a common thing that I use when I'm in the terminal, like after I've done with one sort of session, one thought, hit reset, clears the screen and clears all the variables that you have, gives you a totally fresh shell connection. And so we'll use that to start our for loop syntax now. In Bash or in POSIX for for loops, the syntax is for I in, and then we'll do 1, 2, 3, 4, 5 like this, semicolon. So I'm going to type it all out and then I'll explain. Echo, $I, done. Here I've typed the for loop on just a single line. The I right here is the variable that I'm going to have access to inside of the for loop. And these things between the in and the semicolon, these are the values that I'm going to loop over. The way you know which things you're looping over, like the distinct items, is that there's a space in there. So 1, 2, 3, 4, 5. I'm going to loop over each of these values. I will take on each of these values in turn. After the for loop, you always have this semicolon do, and then what happens after the do is the body of the for loop, the thing that'll get executed each time, and then you terminate it with a done command like this. So I hit enter, and we print out 1, 2, 3, 4, 5 over here. The first way that this gets confusing and interacting with the quotation marks is that I can put quotation marks over this part over here with this echo command. So if I put the double quotes like this, it doesn't change anything at this point. But if I were to put the single quotes like that, then it does change things, and we get $I everywhere instead of the numbers. So you have to be careful about the double quotation marks versus single, always when you're doing shell programming. Any questions so far? Yes. Sorry, where are you referring? This one right here? So if I had done backticks is the question, and what's going to happen is that the expansion here will occur inside of the backticks. So this $I will be replaced by the values 1, 2, 3, 4, and then 5. These are not going to be valid commands. Like it's going to try to run the command 1. That's not going to be a valid command, and so we'll get an error message saying it's not a valid command. Then it'll try to run 2, get an error message saying that's not a valid command, and so on for each of these. I could make this into a valid command by doing something like echo $I like this. It'll do the expansion, print out what the result is here, then pass the result of this to this echo right here. And so that is the exact same thing as that, which is also the exact same thing as that. Good question. Any other questions so far? Okay, the next weird way that quotation marks are going to be involved here is what happens when I have quotation marks in the stuff to the right of this command over here. So let's say I put 1 and 2 separately into quotation marks, and then We'll also do that one in quotation marks. Now, the for loop is going to identify this entire thing as one parameter and this entire thing over here as the second parameter, and this 5 by itself as the third parameter. Hit enter. We can see that this echo over here, these two things are being created, or these two things are being listed at the same time by themselves, one per line, and then 5. So I said before that the spaces are what separates the items that we're going to iterate over, but the quotation marks can override that, grouping things together, ignoring this space right here. The quiz problems, let's go ahead and set up a quiz problem really quickly so that we can see the weird, way that this is going to Victor quiz, C quiz. So I'm in an empty folder right now. And what I want us to see is with these for loops, what happens if I change this echo command right here to the touch command. Recall that the touch command is going to create a file with the name, whatever the name of the file, whatever we pass over here, that's the name of the file that touch is going to create. So I hit enter, I'll do ls-l. That -l again, one file per line, make it easier for us to see how many files there are. There's 3 files created right here. If I were to change this right here, instead of having double quotation marks, to take this out like that, then here, the very first time we run through this for loop, 1 and 2 will separately be passed, evaluated right here. And so this touch command will expand to touch 1, 2, instead of touch 1 space 2. Make sure that's on one line. So 1, 2 without quotation marks instead of 1, 2 with quotation marks. Because there's no quotation marks right here, the touch command will interpret these as 2 separate files to be created. And so it will create not these 3 files here, but 5 different files, 1 for each number. Run that, type ls-l. We can see we still have the 1, 2, and the 3, 4 that we created earlier, but now there's the 1, 2, 3, 4, 5, each of those files created individually. So again, lots of weird ways that these quotation marks can interact with each other, and you'll have to know that for the quiz. And again, the practice problems have lots and lots of interesting variations like this to practice with and make sure that you're understanding. Any questions about, yes? Say it again. I'm sorry, I can't hear. What 0 stands for? That right there, total 0. I forget. It's nothing useful. And yeah. Well, I think I know, but I just don't want to say because it is nothing useful, and I've never had to use that number. And it would take us down a big rabbit hole. So not useful. But good question. Any other questions? Okay. Then we're going to switch from stuff we're going to talk about next is not going to be related to the quiz, but will be useful terminal knowledge, things to know for while you're working. And so what we're going to talk about next is some special variables that are built into the terminal. This first of these special variables is what controls our prompt over here. So this, again, everything to the left of this $ over here is called the prompt. And we can control what gets printed to the prompt. When you set up the Lambda server configuration files in the first lab, you changed what was going on in this prompt. And the way you did that was by actually changing the value of a special variable called PS1. I'm going to do echo $PS1 right here. And when I run that, you can see that this over here is actually the code that gets evaluated every time a new line is displayed, and it runs that to determine what the prompt is right here. If I say export PS1 equals just a $sign like that, then my prompt is now just this $sign with nothing else associated with it. Turns out there are 6 of these special PS variables that control different display formatting on the Lambda server, but this PS1's the most useful. I will occasionally, like when we get into like subfolders and subfolders, sometimes this prompt over here gets too large. And so I often run this just to give myself some more space on the terminal so that things don't line wrap too easily. When we're inside of Docker as well, here in a little bit, we'll see that the different Docker systems will give us different prompts. And the way they're doing that is by changing this PS1 variable. Yeah, this one's not super useful in practice. Usually you just set this once, like when you're configuring your system, and then forget about it. But one that is extremely useful in practice is this path variable. You can do echo $path like this, and this is the results we get. Path is the list of directories that your shell will look for commands. Every time you type in a command on the terminal, that command corresponds to a program that is somewhere on your hard drive, on your computer. In a little bit, we're going to be talking about the Docker command like this. If I type Docker, you can see that, let's see, let's not do Docker. What is another command? We'll do cat. Well, yeah, I type cat. We know what cat does. If I want to know like where cat actually is on the computer, you type which cat like this, and it shows you exactly like what is the full path to the cat program right here. This cat program is located in the /bin folder, and the way that our computer knows to find this program is that it goes through our path, looking from left to right, colons separate folders in here, going from left to right, looking in all of these folders for a program named cat, and eventually it finds this /bin folder right here, and there's a cat folder inside of there. And the which command always tells you where to find that. I'm not sure why Docker, off the top of my head, says it's not there, because I was expecting it to be there, and we're going to overwrite the existing Docker command here in a little bit with a new local Docker command. But these are the two, or this path variable is going to be very important to us later. So it's definitely one to make sure that you'll understand. But again, nothing that will be quizzed on. Yeah, so the question is, repeat one more time what exactly the path command is, or what exactly the path variable is. And it's a list of directories. Each directory is separated by a colon. And every time you type in a command into the Lambda server, it's always going to look in your path for that command. So this cat command, it's not something that's built into Bash. It's not built into the terminal. It's literally just a program that is sitting at this location right here, /bin/cat. And when you type in cat, the way it finds where that's located, which command to actually run is it will go through here, left to right, starting at this location. There is no cat program there, so it tries this one. There is no cat program there, and keeps going, eventually getting to this /bin and finds the cat program. If you put the which command in front of whatever you're running, whatever command you tried to run, it will tell you where that command is located on your file system. When we get to the installing Docker here in a little bit, this will be important, knowing this path command, or this path variable. Another important built-in variable is the home variable. Echo $home tells you what your particular home folder is. So anytime you're writing a shell script and you want to like add something to the home folder, it's just $home. We'll put it there. We'll get you that folder. You can build up a variable. So pwd, I'm currently in the quiz folder, cd ... pwd. Yeah, well, I'm gonna bring back my previous little bit nicer prompt up here. There's a couple ways that I can do that. One is by just logging out and logging back in. Another way is if I do ls-a right here, here's all of these files. This .bashrc file gets executed at the very beginning of every session when you log in. And this contains the code that exports our PS1 variable. If I type vim.bashrc/ps1, you can see down here, export ps1. That's what's setting what the prompt is equal to. I could copy and paste that to recreate this, or I can do what's called sourcing this file by doing .space.bashrc like this. And this dot right here says run whatever this next file is inside of bash, just copying and pasting those commands. So this is always the very first thing that happens whenever you log into the Lambda server. And so I just redid that to get my prompt back down here. I'm going to, so on our little schedule here, I had us going over the MapReduce stuff before going over Docker, but I want us to just go straight into Docker. We'll talk about this later since we're already talking about the material that we needed for that. So we're going to go over into Docker next. And in order to do this, in the topic 2 Docker folder that I just posted earlier today, there's all the information about Docker. We're going to do a quick 5-minute introduction to what is Docker, and then we're going to go through on the command line together and get Docker installed and see some basic usage commands. And this will bring us back to that path environment variable and some of the things that we were just talking about. So high level idea, let's see. Under this pre-lecture work section, you don't have to do any of this stuff, but these are some interesting videos, especially this first one up here. If you haven't seen Richard Stallman, RMS, talk about GNU and Linux, then I'd recommend watching this one. These other ones down here are more background information about why people care about Docker. So Docker itself used basically everywhere. There's this website, stackshare.io. If you click on this one, stackshare.io/Docker, it tells you which companies are using Docker in their systems. So here's just some of the top ones, Pinterest, Shopify. Let's make this a little bit bigger. Twitter, Robinhood, lots of major billion-dollar companies down here. Over 8,000 companies registered, and then lots of different developers using Docker. So very, very widely used. And the question is, why is it so widely used? What Docker is going to do is it's going to give us a standard development environment. So the basic idea is this: different computers have different versions of libraries installed. That the Lambda server has Python 3.6.9 installed. Your laptops, computers all probably have different versions of Python installed. And then not just Python, but all the different Python libraries. You probably have hundreds of Python libraries installed at this point, all with various different versions. And how can we make sure that whatever you're working on your computer is going to work on the Lambda server, on computers in the cloud, and everywhere? And Docker will give us this tool to make sure that all of our computers have the same environment, have the same versions of all the different libraries. So again, a basic idea: if it works on any machine, it will work on every machine. So some comics you can take a look at. Downside of Docker, it's a little bit hard to learn because there's a lot of different concepts that all work together, and you really can't fully understand any one of those concepts until you understand all the concepts. So it's kind of like Git and GitHub in that way, that you kind of have to understand everything before you can start really making sense of the little bit of details, but it's even worse than that. So it's okay if like you don't understand 100% of everything that we're going over, but after we'll finish talking about Docker 2 weeks from now. At that point, if you don't fully understand everything, you should go back and double check, redoing things once you have the big picture. Couple of so long form references here, exactly what is a container there, and this getting started of Docker here. If you want a printed reference, read something about Docker that's maybe more detailed than our lecture will be, then those are the things to read. But today, what I want us to do is make sure that we're able to install Docker, and we're going to do something called rootless Docker. Root of a Unix system is like the administrator of the system, and the normal way to install Docker requires that you have these root permissions. We're going to install rootless Docker so that you can install it just on your account without having root access. If you click this link right here, that'll take you to the instructions for doing the install. I have that opened over here. And when you first come to this page, it probably has this tab, the with packages, opened. You want to click on the without packages tab, and that'll have the instructions that we're going to follow. If you remember from before, the curl command will download the contents of this URL right here. We can go, I'm just going to open up this URL inside of a browser tab for a second. And you can see that this is a bunch of like shell commands, defining some variables, and it's got a whole bunch of stuff going on. So when we do this command right here of curl and then pipe into sh is our shell, and it's just going to pass all of these commands one at a time into the shell. There's a common way of installing things in Unix. Or in Linux in particular. It's a little bit dangerous because like we don't know what's actually in here at any moment in time. This file could change. The NSA could potentially intercept the communications and install whatever other commands they want in there to run arbitrary code on our computer. But it's a common thing to do, so we'll go ahead and take that command, copy and paste it. Again, we know it's a terminal command that it starts with the $ right here, but we're not going to copy and paste the $, just the stuff after the $ into the shell. You do that, we'll download a bunch of stuff. And eventually you'll get output that looks something like this. Yes, question? Do we have to connect it to the Lambda server? Question is, do you have to be connected to the Lambda server to do this? And the answer is that all these this command will run on your own computer, and you'll install Docker on your own computer. But you will need to have Docker installed on the Lambda server eventually in this class. So I recommend going through these steps right now on the Lambda server and installing it. When you run all these commands, you type ls in your home folder, you'll notice that this new folder bin has been created. And we can, if we do ls bin like this, we can see these are all the different programs contained within Docker, and we'll see how to use them in a little bit. But this Docker command is the first one that we're going to do. And in order to run it, we could do bin/docker like this. So we can explicitly tell the shell where this Docker command is to be found. It's to be found in the bin folder. And then there's lots of different parameters that we can pass to Docker, but the simplest one is just ps like this. If you do that and hit enter, you know everything worked because it gives you this one line output like that. We really don't want to have to type this bin/docker though every time that we're going to try to use the Docker command, especially since I'm not always going to be just in my like home folder like this. That if I was currently in a quiz folder, then in order to access this bin folder, I can't do just bin/docker anymore. If I try to do that, we'll get this no such file or directory because there is no bin folder in this folder. The bin folder is in my home folder, so I'd have to do something like /bin. So taking me up to my parent folder, taking me out of the quiz folder into my home folder, and then doing bin/docker. And that now works. But it's really inconvenient to have to do this command, change the command every time you want to run this program. So I'm going to go back to my home folder, and let's take another look at that path environment variable, echo $path. Sort of the fundamental problem is that this bin folder is not in my path. That if I just type docker like this, again, that docker command is not found. It has to be bin/docker for it to be found. I have to explicitly tell the computer where to find it because that bin folder is not in this path anywhere. I could add the bin folder to this path. And if we scroll up a little bit, this right here, this command right here is suggesting that I add the bin folder to my path. The way it's doing that is this folder right here, this path right here is the bin folder. Here's my home folder to the left with the bin folder inside of it to the right. And it's putting that as the leftmost position inside of the path environment variable and then exporting that. I could run this command and it would be fine if you chose to run this command. Personally, though, I don't like having this bin folder inside of my home folder because I think it just clutters things up. I don't want to see that bin folder every time I'm working because I'm never going to manually go inside that bin folder. To me, that bin folder is something that I shouldn't have to think about. And so what I like to do is I like to put it into a dot file. Again, dot files are things that you only see when you have the ls-a. And it's traditional to put it inside of this .local. Inside of .local, I currently don't have a bin folder, but any of these binary programs, bin is short for binary, any of these programs that I want to execute easily, it's traditional to put them in a bin folder inside of the .local folder. And that way you don't have to see them. They're there, we can find them if we need to, but every time I type ls in my home folder, I don't have to see that bin folder. So the way to move this bin folder in here is just move, mv short for move. Bin is the name of the file that I want to move, and then the new location that I want to move it to. So move the current bin folder into the .local folder like that and hit enter. And now if I type ls in my command line down here, that file doesn't exist. Or that folder doesn't get displayed. I could still find it by doing ls-a if I wanted to. But now if I type just docker ps like this, because echo $path, this right here it is, that .local/bin is contained in my path. It's going to find that docker command for me, and I don't have to manually type that in every time. Any questions at this point, what I've done? Is this, how many people this all 100% made sense, everything that happened? Not many? How many people have this working? Like if you type docker ps, it actually does that. Okay, lots of hands and thumbs up. Okay, as long as it's working, that's the important thing. The other parts are nice to know about why all those things were there, but not strictly necessary. One more step for us to do though before we're done with the installation. And I'm going to scroll back up to the output. So again, this big thing right here is the output of my installation curl command. I'm going to go to the very last line. Down here, these two lines right here. So we've taken care of this path part, and we did it by just actually moving the bin folder to something that was already in our path. But this last thing right here, this docker host line right here, And exactly what your Docker host line is going to look like will be different than mine. You'll have a different number right here, probably. This number right here is something called your user ID on the Lambda server. What we need is for this line to get run every time we log into the Lambda server. We need this Docker host environment variable to be set. In order to do that, I'm going to copy and paste this line right here. So I'm just copying it right now. It's now on my clipboard. And I'm going to open up that bash rc file, vim.bash rc. Again, this bash rc file is something that gets executed immediately when you log into the Lambda server. And so I want this export line to be executed whenever I log into the Lambda server. And I'm going to go down to the very bottom of this file by pressing Shift-G and then just pasting that as the last line in my bash rc file. So everything up to line 111 is something that is standard that you should all have, but then line 112 would be different based on what your Docker host is. Press Escape, :WQ to save that. Again, this last line right here is the last line of the output from your installation script. Yeah, so I'll just restate everything that I just said. That up here is all of the installation script. And you can see this very last info statement right here says, make sure you add the following environment variables or add them to your ~/.bashrc. And so we already took care of this by moving the bin folder into something that was in the path. Now this very last line right here, this Docker host variable, this is something that all the Docker scripts need to have access to. And so by making it an environment variable, it's going to make sure that all those programs will have access to it. I just copied this line and then opened up the bash rc file, vim.bashrc, press Shift-G to go to the very bottom, and then paste it right there. Did that answer your question, Maria? Anyway, yes. If your command ends in something like this, then it was successful. This ls command right here. So these are all different files that have been created at different points. You will likely have different things in your home folder than I do. Okay. Yeah, I have a folder TMP in here, or a file. You may or may not have something like that. It's okay. As long as you can run Docker PS, then you're good up to the point of adding that last line to the bash rc file. Yep, you just want line 112 will have this export command inside of it. And again, this is going to allow all the different Docker commands to communicate with each other because they'll all have this Docker host environment variable set. Yeah, well, let's see. This, you'll notice that it looks kind of like a URL because it has something : / over here. It doesn't have HTTP. It doesn't have this thing to the left of the colon. It's called the scheme of the URL. This scheme Unix means that it's only going to be happening locally. So there's like a local web server sitting at this URL that all the other programs can communicate with each other on. So let's see. And also notice at this point, this variable called Docker host. If I do echo right now, $Docker_host, you can see that there is no value set for the Docker host, that command did not get run for us automatically, that export command. The instructions at the end of the install script were telling us that we needed to run it still. And so this environment variable not set. But now if I source that bash rc file by doing .bashrc like this, .bashrc, it'll rerun all those commands, the very last one being the export Docker host. And now you'll see that that thing is set. And furthermore, if I exit, log out, log back in, and rerun that echo, because as soon as I log in, that bash RC file is automatically run for me. This Docker host environment variable will now always be set, and all of our Docker commands will be able to communicate with each other. And one last Docker command for us to do now at this point, just for us to get a flavor of what we can do with Docker. And then we'll next time going on to the more complicated things. But there's a command called docker run, and we'll talk about exactly what this -it does later. But this is the command that we're going to try: docker run -it and then Ubuntu. And I'm going to hit enter right here. A lot of things are going to come up on the screen for us, and then eventually we get this new prompt down here. All of this stuff, what it was saying is that it was downloading a sort of a template for a new computer environment. This computer environment happens to be running the Ubuntu operating system. And then it started up that computing environment, and we're now inside of that Ubuntu computer. We didn't give a name to that computer in any way. So this right here, this long random hash, is like the name of that computer. And we're inside of that computer. There's no way for us to get from this back to the Lambda server. It's like we're in a totally separate machine. And now if I type, and we can see that we're logged in as root. And if I type ls, here's all the different things. If I go into the home folder, cd home ls, you can see there's no contents in this home folder because like it doesn't have your home folder from the Lambda server, because you're not in the Lambda server anymore. We're in this new special Ubuntu machine. I'm also going to open up a separate terminal window here for a second and log in to my account. So both of these two terminals logged into the Lambda server on the same account. And over here, if I type this docker ps command now, it's going to give me a list of all of these computers, all of these virtual machines that I have running. Here under image, Ubuntu, you can see it's because I launched an Ubuntu thing right here. And yeah, and so down here, we're actually interacting with that Ubuntu machine. Over the next 2 weeks, we'll be talking about how to do really cool stuff with this Docker, spawning hundreds of computers and making them all work together to display web pages or process information. And in particular, we're going to build the actual infrastructure backend that Instagram uses. So that's just a taste of what these things are doing, what you can do with Docker. If you can do these, you know you're in a good state, that everything's worked, and you'll be able to follow along on Wednesday. But any questions at this point? Yes. Question is, how do I get from here back to the Lambda server? If you type exit, it will exit out of that. Okay, that's it for the Lambda server. Today we're going to switch back over to GitHub, and I want us to now talk about the MapReduce homework assignment that it's not using Docker at all at this point. It's just using the material from last week and the shell scripting and the parallel programming stuff. So under this topic 1 MapReduce, if you click on the homework folder here, here are all the instructions. The submodule up here does not have the instructions. Inside of here, there are the some starter code for this project. And then down here are all the instructions. The first thing to notice about this project is the due date. So you have a little over a month to complete this project. The main reason for that, again, is just that computing, if all of your computing operations are spread out over time, it won't overload the Lambda server, and potentially your code could take up to about 1 week to run, depending on how many other people are running your code while you run it. And inside of this, or the purpose of this project, you'll be using this MapReduce system to analyze all tweets sent in 2020 and to monitor the spread of coronavirus on social media. So we'll first talk about exactly what this MapReduce system looks like, and then we'll talk about the actual assignment itself. Any questions though before, like administrative questions before we get into the what to do for the assignment? Some of you, I think maybe 2 or 3 of you, have completed a very similar assignment to this with me in CS46, but there are some differences between this and what you did in 46, so you will have to repeat this assignment. So background, again, about 500 million tweets sent every day. About 2% of those are geotagged, and so that means there's GPS coordinates associated with the tweets. And this folder on the Lambda server has all of those geotagged tweets sent in 2022. We talked about the formatting of those tweets a little bit. And the key thing here is that every day is going to be in a different file. And so that'll make processing for us easy using this idea of MapReduce. In MapReduce, when we have a large data set, we have these 3 separate phases of computation in order to process that large data set. So here in this image, I have this long DNA strand to somehow represent our large data set. And we are breaking it off into smaller data sets. Each of these small data sets will be represented by one of those individual zip files, a single day's worth of tweets. And so this partition step is already done for you. I've already partitioned the data. In the map step, we're going to run a file. It'll be called map.py that processes all the information from one of these individual partitions and generates a summary of those individual partitions. In particular, in this assignment, what you're going to be doing is calculating how many tweets use certain hashtags every day. So it's basically just a counter of how many hashtags get used on each day that this map is doing. In each of these steps, they don't depend on each other, so you'll be able to run them all in parallel. And you'll use the techniques from the lab to run them in parallel using that nohub command and the ampersand to make them all run in parallel. And after you do that, you'll have the output of a bunch of files, and you'll do this reduce step that combines those files together. Again, the information that we're computing is just like a count of how many tweets got sent. And so if we were just add those counts together in this reduce step, then we'll get the total number of counts that happened over the original large data sets. There's 3 background tasks here that I encourage you to run on your own to make sure that you can use the starter code that I gave you. Inside of the source directory, there's a map.py file. And if you run that, you can run it like this on an individual file. It will generate just a dictionary counting up how many times certain tweets are used. I'm going to come over. Here we go. Let's close out of this. There we go. ls cd project cmc. There we go. ls cd. I don't think we've gone over this in this class yet, but so my contents down here is behind what is currently on GitHub. Or actually, I'll do it a different way, an easier way. I'm just going to clone the Twitter coronavirus repository, https://github.com/mikeispicky/Twitter coronavirus cd Twitter coronavirus ls. Inside of this src folder right here is your starter code. Inside of that is your starter code, and then src/map.py. Here's your starter Python code. These are the hashtags that you're going to be looking for inside of all of the tweets. The very first ones up here are non-English language things, so your code will have to be generic for all of these languages. You don't really have to do anything special for that, but it's just nice to know that you can do that. And then all the different, or a handful of different tweets related to coronavirus in different ways. You'll be searching for those and counting up how many times each of these tweets are used. In this code down here, there's a couple of, So looping over all of the contents of the zip file down here, 4-line in F. And here's where it's going to be doing all of the processing about actually counting up how many times each hashtag is used. And then at the very end, it's outputting a JSON file, a JSON dump that summarizes all the hashtags that it found. So this first step right here, just making sure that you're able to do that. And then there's a visualization step, this visualize.py. You run this and it'll show you a slightly more human readable version of this, the output of map.py. Eventually, as part of your assignment, you're going to have to change this visualize.py so that it's outputting not just like a text summary, but actually an image of like a graph of how many times the this hashtag was used in different countries. And then this reducing step, if you do the map.py, you run this on multiple different files, and the reduce step will combine the results of those files together and to get you one single output JSON file. The key thing about this is that this visualize function, it doesn't matter whether you visualize the output of the individual map. It doesn't matter whether you visualize the output of the individual map or you visualize the output of the reduce step that merged those two map files together. You can still visualize the output and get a good output from that. So you run these commands, make sure that you can get them working. Question?
Does it matter if we just pick on this repository versus update?
Yeah, so the question is about cloning this repository, and I'll expand on the question and why exactly did I clone this repository instead of updating the previous repository. The easiest thing to do to get access to the starter code is to do the git clone like I did up here. If I go back to the repository right here, I can update my repository using git pull origin 2023 spring like this, and or git remote. This is going to my example student repository right now. So git remote add https://github.com/mike is Vicky /cmc-csci 0143 like this. So git remote add upstream, and now git pull upstream 2023 spring and update the contents of my repository like this. The git pull command fetches from whatever the URL is that I typed in right here. The git pull command updates the contents of my repository with whatever is at this URL right here. So I've now updated everything. If I go into the topic 01, we can see there's this homework folder. If I go into homework though, we can see if we go into the Twitter coronavirus where the repository is, we can see that this is empty at this point. This is what's called a Git submodule. All of these Git repos that are inside of other Git repos are in these Git submodules. And git pull does not, and git clone do not get the contents of Git submodules. There's another Git command, which I don't know off the top of my head, I'd have to look it up, which would get the contents of those Git submodules, and we could get the contents of the repo that way. So you can do it that way, it's longer, or you can just git clone of the final repository. I don't know if that answered your command or if it was much more than you asked.
Yeah, so we can just clone this.
Yeah, just inside of your project folder or whatever you put all your projects, just run git clone on the Twitter coronavirus repo will be the easiest way to get access to that starter code. Good question. Any other questions at this point? Okay, there is, let's see. I'm intentionally being a little bit vague about the things that are required for this assignment. And intentionally not covering certain obstacles that I know you all will run into. so that you just get the experience of running into these obstacles and having to overcome them. I'm so happy to answer any questions that people have, and I'll help you work through those obstacles when you get to them. But I want you to just have more experience running into problems and trying to figure them out. So yeah, that will be all that I will say about what all the knowledge that you need for the assignment. The actual tasks down here, 4 steps that you should do. You'll have to modify the map function to do a little bit more computation. You don't have to modify the reduce file at all, but you'll have to create a script that runs it using the NoHup and the ampersand operators. Then you'll run the, that should say visualize. You'll have to modify the visualize code to generate the image. Again, I'm not going to tell you how to generate images, how to generate graphs, but here's a link to some documentation that you can use. And then some instructions for uploading your file to GitHub. So unlike the first assignment, this assignment has no continuous integration related to it for 2 reasons. One is that I don't really care about nitpicky details like whether you consider uppercase versus lowercase things, that I care more about just you're able to use the NoHup and the ampersand to get these systems created. Another is maybe more important, that there's multiple terabytes of data that you're analyzing here, and continuous integration doesn't work well on these large data sets, that we can't upload this entire data set to GitHub every time you're running tests. So there's no continuous integration. For this assignment, I'll just manually look through things to check that things look reasonable. This last task 4, though, you'll have to modify the README of the MapReduce of your project. And one of the things that I recommend that you keep in mind while you do that, the README is currently empty. Put enough explanation in there that if a future employer were to look at it, they would be impressed about what you did. Talk about how it's multiple terabytes of data and every tweet sent from 2020 and so on. And this would be a good sort of project to like bring up with people while you're interviewing about the cool things that you have done and can do if you get hired at a company. If anybody has any further questions, I'll stick around and make sure those get answered, especially if you didn't get the Docker stuff installed. This is a good spot for us to stop for today. And so I will see you all on Wednesday.
I have a game folder in my document.
Hmm?
Yeah, I just read that.